Hi, in this video I'm going to talk about a neutron star with a bizarre magnetic field. The particular object about which I'm going to talk about is GRO J2058+42. This is the name of the object, the neutron star, that is part of the discussion in this video. Now, recently scientists from Russia, Finland and the Netherlands have reported in the prestigious Astrophysical Journal letters about an interesting behavior in this object, which is atypical of a neutron star. First, let us try to understand what is this neutron star. A neutron star is nothing but a remnant of a star. If one studies the evolution of a star from the time of its birth till its final stages, one would understand that depending upon its initial mass and its evolution phases, a star can go to different fates. One such fate is, for example, the neutron star. So, a star can become a neutron star, or it can end up as a white dwarf, or it could become a red giant, or of course the very popular black hole. So different possible fates of a star. So neutron star, under certain conditions, a star becomes at the end of its lifetime. So a neutron star is nothing but after a supernova explosion of a stellar object, whatever is remaining, the remnant, is a neutron star. Now, typical size of a neutron star is about roughly a few kilometers, of the order of about 10 kilometers, but the mass is heavy. That is, it's very massive. Typically, neutron stars will be about 2.5 solar masses as well, of 1.5 to 2.5 solar masses. So it's so heavy, but in a small radius. So the object is very small but very massive. So the densities are very high, heavily dense object. The densities of neutron stars are comparable to nuclear densities, and hence the name neutron star. Right. Such objects are considered to have neutrons, basically. So they are composed of neutrons and a few protons as well as electrons. So for charge neutrality, there has to be equal number of protons and electrons, but that is only about 10 to 20%, and the remaining is fully made up of neutrons, and hence the density, the high densities are explicable only in terms of composition, in terms of neutrons. So the entire star is made up of what is called the nuclear matter, and hence these are very interesting objects in the cosmos. So scientists have long been interested in studying neutron stars for a very interesting behavior, magnetic behavior of neutron stars. So these neutron stars have very strong magnetic fields associated with them, just like our Earth or the Sun. But the magnetic fields that we are talking about in the case of neutron stars are trillions of times larger than the Earth's magnetic field. The typical magnetic field orders of neutron stars could be from about anywhere from about 10 power 11 to 10 power 13 gauss. These are very high magnetic fields for any stellar object, and therefore these are very interesting objects of study. Their magnetic behavior is constantly studied. Many such neutron stars are being pursued in current research, and this object GRO J2058+42 turns out to be one such interesting object. This object was discovered about 25 years ago, and recently scientists in Russia and Finland and the Netherlands have given a lot of attention to this object because they were waiting for its activity. What do we mean by activity for this neutron star? Such neutron stars spin about their own axis at great speeds, and when they spin like this, and if they approach any other nearby object, then a lot of matter from the nearby object gets accreted onto the neutron star, and therefore the velocities with which the matter is being consumed by the neutron star is enormous, and therefore radiations are emitted by the neutron star. Typically, a radiation that gets emitted in such objects predominantly lie in the X-ray region of the electromagnetic spectrum. So, typically such neutron stars are studied using X-ray telescopes. Right. Recently, using the help of the American scientists from NASA, using an X-ray telescope called NuSTAR, these scientists from Russia, Finland, and the Netherlands observed this object to show a bizarre magnetic behavior. What is so bizarre about this behavior? Right. The moment a neutron star starts accreting matter from a nearby object and start emitting X-rays, very intense pulses of X-rays. For example, in the case of a lighthouse, we see flashes of light emanating from the lighthouse because it's spinning. The same way, when a neutron star is spinning, it starts emitting pulses of very high intense X-ray jets. Now, from Earth, if we try to observe such an object, we get flashes of X-ray beams. Very feeble, but very measurable. When such X-rays are emitted, these neutron stars are called X-ray pulsars. Now, scientists have observed a lot of such interesting pulsars, and their behavior is very well documented. When the neutron star is just spinning without accretion of matter, it does not show any signatures of magnetic field because we cannot detect it from here. But when it starts accreting matter, there is a correlation between the X-ray expulsion or emission from the neutron star and its magnetic field strength. Therefore, during the period of high activity of accretion and X-ray emission, these neutron stars become interesting objects of observation using such very interesting sophisticated telescopes. So, during their observation of this particular object, these scientists have observed that the X-ray pulses that is emitted by this particular object does not exactly correspond to an increase in its magnetic activity. Normally, when these two things are neutron stars, these two things are always observed to be in correlation. That is, during the entire phase of rotation, there is emission of X-ray jets, and the period of rotation of the object and its magnetic strength can all be measured during such emissions. But for this particular object, the scientists have found that the X-ray emission and the intense magnetic behavior do not correlate, they do not match. That's why this object is considered to have a very bizarre magnetic behavior, and that's why this is very interesting, and it has been in the news recently. Because if such neutron stars which are not typical or observed, then this could throw up a lot of interesting understanding about the internal structure of the neutron stars, because scientists with the current understanding have an idea about the internal structure of such objects, but the origin of the magnetic field in such objects is not very clear. The sizes are very small and the densities are very high, and the rotational speeds are high. The magnetic field generated is enormous, huge. Nothing that we know of in Earth has such huge magnetic fields. So this is all very interesting. But then, when you see such exceptional cases with a strange magnetic behavior in neutron stars, then such objects deserve a lot more attention and focus in research. And I'm sure in the near future, a lot of focus is going to be on this particular object. Very interesting, strange cosmological object. And this could throw up a lot of interesting new physics in the years to come. Thank you.